Roadmap to Clean Energy using Laser Beam Ignition of Boron-Hydrogen Fusion. Number 5. Need for very high contrast ratio of petawatt picosecond laser pulses. The experiments for the studies listed in the preceding section may be performed with laser of the usual quality with petawatt picosecond pulses. However, very extreme quality is necessary with respect to the contrast ratio for measuring the single beam initiation of the ignition processes. Characterized by the blue deeper shift in the reflected light. These high-class laser beams were well available, but only in the very rare case of with the KRF lasers used by Sauberly and Ford's ETAL and by the extremely precisely developed solid-state laser used by Shang ETAL and by Bad Ziak when Sauberly tried to repeat the measurements at Rutherford Appleton Laboratory with much more powerful KRF lasers in cooperation with many top-class physicists. The results could not be reproduced. The same happened when Badzike was invited to use the solid-state lasers at the École Polytechnique in Paris. The pioneering results of this could not be reproduced. The reason was very evident. The lasers for the reproduction were not good enough for using the single beam ignition of the HP11 fusion. See Figure 2 and 3 in difference from multi-beams. For spherical irradiation, Figure 1, the fusion fuel is not spherical but of cylindrical geometry. Figure 5, with trapping the reaction plasma by ultra-high magnetic fields of several kilotesla. Use is then made from the extensively studied non-thermal driving of plasma blocks by the non-linear force. Figure 4. The 10 to the 5th power times higher acceleration than ever measured before in a laboratory for interacting within picosecond laser pulses, giving velocities of more than 1000 km per second, was measured from the blue Doppler shift of reflected specular lines. This blue shift is in exact agreement with the theoretical predictions from the hydrodynamic computations. The cylindrical fusion flow is shown in the axis of the coils of Figure 3, and the irradiation by the single ignition laser pulse is shown end-on at the cylinder of the flow. The details of the description of the HP11 reactor are based on extensive results of the plane wave plasma block generation with detailed experimental and theoretical confirmation. It should be noticed that the new HP11 clean fusion reactor may be listed under the category of fast ignition by TABAC, but it is essentially different from usual schemes, as no plasma compression etc. is needed for the new HB11 case. For designing the next following experimental confirmation of the ignition processes by bigger than petawatt picosecond laser pulses, it is necessary to underline the required extremely high contrast ratio of those laser pulses. This contrast has been verified in the preceding experiments and can be taken over from there, but this needed very sophisticated laser technology. It has been achieved in the experiment with KRF excimer lasers, and only the most exceptional attention and experiments did clarify the conditions for excluding relativistic self-focusing by using solid-state lasers. Convincingly demonstrated by G.A. Chan, it is important to note that the solid-state lasers within this extremely high contrast were fulfilled in the unique experiments showing the nonlinear force driven plasma block acceleration directly from the skin layer acceleration. Replicating these experiments in other countries by the same expert did fail due to the insufficient quality of the used laser with respect to contrast properties. This insufficient quality of the usual laser pulses can be seen from the broad-stream experiment resulting in the red Doppler shift instead of the blue shift. This could be understood by using PIC computations with plasma densities below critical. The very difficult calculation at critical density were mastered only by J.W. and his team recently as a test whether the petawatt picosecond laser pulses have a sufficient contrast ratio. Maybe that the light reflected from the irradiated target has to show a blue Doppler shift of spectral lines. Any other lasers cannot be used for studying the non-thermal plasma block ignition at the direct drive on the cylindrical end of the HB11 fuel. When checking earlier experiment, it was elaborated that the extremely unique laser fusion experiments by Nori et and Clark were so exceptional and significant because there seemed to be, at least for a short period, laser pulses available with extremely contrast conditions. When re-evaluating the fusion gain with a 100-to-1 increase when estimating the dt value from dd, the absolute record gain of about 0.3 was achieved. This is the highest than ever preceding gains by laser-driven fusion and the highest gains ever reported from two Kamak experiments. Thank you.